Hello, friends. So we're back on Desmos here because I think this will be good, a good visual for the topic of this video is it's the second derivatives in the idea of concavity, and so I just so let's illustrate this first with a function. So when we have like our f of x equals x squared. Remember what the derivative, actually, I'm just going to translate this up so that we can kind of see it a little better. So remember what the derivative represents. So the derivative, so when we take the derivative of this function, when we take d by dx, that's gonna of x squared plus 5, it's gonna equal 2x. And what does the derivative represent? It represents the rate of change. So wherever this function is increasing, that derivative is positive. When this function is decreasing, that derivative is negative. And so when we look at this visually, like we can see that. So when this is below 0, our function here is decreasing. When this is when the derivative is above 0, our function is increasing. And its rate of change is given by where the derivative is at the time. But what we see is that the derivative is a straight line. So the rate of change of the derivative is always the same. And so that's what the concavity is. So now when we take our second derivative, so if this is our f of x, and this is our f prime x, and what's the second derivative of that going to be? Well, we take the derivative of 2x, which is just 2. And so when we map our second derivative, that's just 2. And so this is the same everywhere, and this is always positive, and that's because the concavity. So whenever the second derivative is positive, we call that concave up. And we can really see that from the picture of this graph, right? Like it's concaving upwards. Its rate of change is always increasing by the same amount. That's really what the idea of the second derivative is. And that's really what I kind of wanted to show in this video graphically, because I think that that really helps kind of build that understanding. So let's look at, for example, x cubed plus 3x squared. So when we look at this function right here, we see that its concavity shifts. And so we see like right here, this is where, right here, its concavity is downward. And right about here, its concavity shifts upwards. And so let's look at, so if this is our f of x, then when we take the derivative of that, f prime x, and we're going to take the second derivative of it as well. So that'll be 3x squared plus 6x. And its second derivative is going to be, we take the derivative of that one, so that's going to be 6x plus 6. So I'm just going to change the color of, how did I change the color? Okay, whatever. So like right here, like let's look at that. I know we got like the 3 functions going on. So maybe we'll just look at the first derivative first. So right here we see where this first derivative, like right here is where it's the first derivative is negative, so that means the function is decreasing. And that matches up because we see from right here, right here, this function is going down. Everywhere else, it's positive, it's increasing. And so the next video is really kind of going to build off of these ideas, and we're going to talk about critical points and turning points. But yeah, like right here, this is really what I just wanted to emphasize, is that the second derivative is how much its rate of change is changing. So the 6x plus 6. So we see right here that where the second derivative is negative, this lines up with where the concavity is downward, where its rate of change is decreasing. And right here, where the second derivative is positive, that lines up where the concavity is upward, its rate of change is increasing. So it's not just that the function's increasing, it's that the rate of change of the function is increasing. Because as you can see, there's some overlap where like the first derivative is negative, so the function's still decreasing, which is true. But the second derivative is positive, so the function is its rate of change is increasing, but the function itself is decreasing. So I really hope that like this visual representation helps clarify like the idea of concavity in the second derivative. And yeah.